My name is Rob Ballard. For those of you who don't know me, I guess a lot of people in here know me. A few of them know my father. You don't, but I know Felton does. Russ Ballard, he used to be, I guess, one of the founders of the club here. When I was growing up, my dad always had a 50-foot tower, freestanding tower with his ham radio gear on it. Usually had about a 30 or 40-foot beam on top. And one time, it got hit by lightning. And my dad was singing the blues. He had a ground rod, the typical, steel ground rod, clamped to the tower leg, blew everything out. Blew out his 1,000-watt linear, got his antenna tuner. He had some sort of capacitive thing at the top, which I guess was an antenna relay. You could switch between 20 and 40 meters, I guess. Got all of it. So next thing you know, I'm climbing the tower and putting new stuff up. So anyway, it was a direct hit, but insurance didn't want to pay everything. They had trouble evaluating ham radio gear. I guess he got probably a $2,000 check after his deductible, which might have been $500 or $1,000, but it was costly. He had an ICOM 745, blew it out. So we didn't do any research back then. I was a teenager. So I was just a tower climber. So anyway, to make a long story short, I joined a company called Skywave Communications. We did wireless internet primarily. We had bridging between towers. We run 5 gigahertz bridging. Is all microwave, high frequency stuff. And the first 2 towers we put up, the first one was 120 foot, pretty tall, freestanding tower, SSV Roan. Second tower we put up was a Roan 25 at 150 foot. Okay. Each one had about $2,000 worth of transmitters and equipment on it. We had GPS sync and Motorola transmitters. We had some Transio Wi-Fi equipment, different things for different customers, different speeds. Well, we quickly found out every time a lightning storm come up, these towers get hit by lightning. The experts say anything under 150 feet doesn't have any higher chance of getting hit by lightning than your house or a tree or anything else. And I disagree. The first 2 towers, every time they get hit by lightning, it was blowing our equipment. So I had to think about what was going on during a lightning strike. Now these towers, both of them had 3 steel ground rods, your galvanized 10-foot ground rods. We had them placed, probably 5 feet out from the tower legs, which now I know is not far enough. We'll get into that. But, the lightning would hit the tower, and even though we thought it was well grounded, it was following the network cables and the coax cables down, blowing out the power injectors, blowing the transmitters at the top. It was getting into the 110 volt because the outlet, we had an outlet there feeding power from a nearby building, it was always smoked. So when we had to fix everything, we had to run a new cable because it destroyed the cable, kinda. Sometimes the cable was okay, believe it or not. But we had to change the outlet along with everything else. And so we started putting grounding adapters or grounding blocks. Like we had a network grounding block to run your network cable through. And guess what? That worked, but it still blew the radio at the top. It didn't go anywhere past that grounding block. So it told me the lightning was jumping into our network cable. Now, why do you suppose that was happening? When you got this big, heavy steel tower, 3 ground rods, why is it jumping into this little 24-gauge wire instead of just following the tower down to the ground? Any idea? Has to do with resistance. Okay, look at your paper. First, we're going to talk a little bit about grounding. There's 2 types of grounding. In essence, the grounding system is a backup pathway that provides an alternate route for electric current to follow back to ground. In the case of a problem in the electrical wiring, like a house, or for lightning protection. We're going to focus more on lightning protection. Most people know what your house ground does for you. It grounds your appliances, so if something shorts out, it trips your breaker instead of shocking you. So it's there for personal protection. Lightning protection is quite a bit different, but they do go together. Number 1, lightning grounding and electrical grounding. What is the difference? There are several types of lightning protection used separately or in combination. ground rods, most everybody knows what that is. Perimeter ring, I don't know if anyone's seen that, but we'll get into that in a minute. Bare wire, radials, plates, and copper mesh designs all constitute acceptable earth electrodes. The lightning ground electrode is a dedicated part of a good lightning protection system. I am friends with Anthony Hodgkins from Hodgkins Construction. He puts up cell towers. So I've had firsthand experience to watch these things get built and the type of lightning protection they put in some of these cell towers. A lot of them use ground rods. A lot of them will dig up the ground 4 or 5 feet deep and lay a big copper mesh and then bulldoze back over it. Just a great big, huge 40 by 40 foot copper mesh, you know, just to get lower resistance to earth. Because that's the whole key to any good grounding system is what is your resistance to the earth. I don't have a earth resistance meter, but they make them. They're kind of expensive, $200 to $2,000. They basically have a couple test probes you put out in the field about 30 meters apart. Then you check your ground rod, and it compares the resistance somehow and tells how good of a ground that grounding system has to the earth. Because no matter how good of a ground you put up, if you don't have a good earth ground, lightning's going to follow a better ground somewhere. And we're going to explain that in a minute. It kind of goes back to the network cable theory I was telling you about. So there's all types of ground systems. Number 2, let's talk about resistance and conductors. Look at the pictures there. I got 8 different pictures. Which ones do you guys think are the best conductor for lightning? It's pretty much the first 5. Okay? You have your 24 gauge stranded copper. Great conductor for lightning. Not a good one, but it's a great conductor. 10 gauge solid copper. That is what, I installed satellite systems for quite some time, put about 1,000 dishes up, and National Electric Code requires a 10 gauge copper wire from any outdoor antenna. TV, satellite, you name it. You should have a 10 gauge copper wire. So that's why that's on the list. And we have a 6 gauge solid copper. Now if you look at the pictures, I have the resistance underneath. 24 gauge stranded copper is about 0.26 ohms per 100 feet. 10 gauge solid copper is 0.10 ohms per 100 feet. These are close estimates. It's real, you know, I didn't put the fractions in there. 6 gauge solid copper is 0.05 ohms per 100 feet. And then you have a 1/2 inch to 1 inch copper strap. The resistance can change. It's typically 0.04 to 0.02. If you had an inch wide copper strap, that's 0.02 ohms. If you look at the next 4 items, you have an LMR 400 antenna cable. A lot of people use that for amateur radio. It's 0.21 ohms for the shield, 0.14 ohms for the center conductor. Steel ground rods are 0.2 ohms, 1/5 of an ohm in 10 foot. Not so great. Copper ground rods, 0.004 ohms per 10 foot. Copper clad ground rods are 0.01 ohms for 10 feet. Or a Roan tower section, which is about 2 ohms in 100 feet. So the problem with just grounding a tower, and I was talking to Dennis about this probably about 2 months ago, and I guess you have a ground on your tower, is that correct?
I have my ground totally wrong.
Right.
Yes.
We determined it was totally wrong after talking to him for about 5 minutes.
Ground rods, each of them a foot away from the leg.
Okay, which is a problem. We're going to get into that. So he just has the tower grounded. Okay, and as you can see, I'm just using a Roan tower as an example, but a Roan 25, 100 feet is, what I say, 2 ohms? About 2 ohms. Okay, say you have an LMR 400 cable going to the top. That center conductor is 0.14 ohms. So during a lightning strike, lightning's going to hit the top of the tower. Instead of coming down the steel, which a little bit of the energy does, it's going to find the best path for that 100-foot or 50-foot tower. It's going to jump right into your LMR 400 cable or your RG6 or whatever you've got running up that tower. And where's it going to go from there? It's going to go inside the house. The majority of that energy is going to go inside the house. It's going to get all your equipment. You're lucky if it doesn't catch your house on fire. Okay? So what does that tell you right there is you got to have a better ground. you can't rely on a steel tower because steel is high resistance compared to copper. Even aluminum. Copper and aluminum are close, which if you look at the next page, we have resistivity, number 3. If you look at the chart, we have different resistivity for different materials. This is measured with a 1 meter cube of material. So if you have a 39-inch square copper block, okay, that's where that number comes from, or 39-inch square copper, aluminum, steel. Okay, that's how they calculate these numbers. So those numbers are pretty low. The problem is, as your material gets smaller, your resistance goes up. That's why your 10 gauge copper had about 10 ohms for 100 feet. 6 gauge has 0.05, half of that. Because there's more material, there's more atoms in the metal to carry the electrons. The electrons have to jump between the atoms. Ideal would be have a 39-meter block going all the way to the top of your tower made out of copper. But nobody can afford that, and we're not playing Minecraft, so, you know. The game Minecraft, everything's measured out in 1 meter blocks. So I suppose if you wanted to build a tower in Minecraft, that's what it'd be made out of. So anyway, that chart is just for your reference there. You can see where copper is a little bit better than silver, a little bit better than aluminum. Aluminum's close. So let's go to number 4. You can go back and read the resistivity later. When you put a tower up, you want to ground it good, and I'm going to explain some good ways of doing that. But the second problem is the ground at your tower, your lightning protection, also has to be bonded to your house, because that's what they call a potential energy rise. If you have a tower 100 feet from the house, 50 feet up, 100 feet up, whatever, you have the best grounding system out there for lightning. It's great. You still have a copper wire coming back to the house for your radio, okay? When lightning hits this tower, all the energy around the ground is the voltage is going to rise, because the ground takes a few milliseconds to dissipate that energy. So your house is grounded over here too to a separate ground, your electrical ground. And it's usually a really good ground. And that's part of the problem with grounding towers is your electric ground is really good at your house. So as the energy rises, say 300-400 volts, that excess surge is going to come back through your coax. That's why it's important to bond your building. If you have a 6 gauge copper out here at the tower going to the top, you also want a 6 gauge going to the house. So it has a different path to follow, okay? Hopefully it doesn't get in your coax because of insulation and other factors. But if you give it a good solid path to follow for that energy, most of it will go in the ground, any excess will charge up the house at the same rate. So your potential energy rises at both locations instead of one. You know, it's like having 2 batteries. You have a dead battery and a full battery. You hook a wire between them, it's going to flow from the full battery to the dead battery. So more energy here from the lightning bolt is going to flow down all your wires unless you have it bonded to the house. Now look at the diagram. There at number 6, we're going to come back to our ground rods in just a minute. Number 6, that's probably what I'd call the perfect ground. Somebody's got a windmill. Look at all the ground rods they have. That is a perimeter ground. It's a radio ground. It's got lots of grounding rods. It also has the bonded wire going back to the building. You see that. It's all bonded to the home electrical, to the telephone pole. The problem is we can't afford that many copper ground rods. Most of us can't. A pure copper ground rod could be $220 for one rod. Now you can get copper-clad steel, which is what I'd recommend. It's the next best thing because it's got a pretty good electroplated copper on top of the steel rod, so it does have a good path to get into the ground. So let's go back to number 5. Multiple ground rods and spacing. The code requires you to space ground rods at least 6 feet apart. Okay, I don't know if anyone's ever read that. However, that is a minimum spacing and far from ideal. When using 10-foot ground rods, you get the best results by spacing the rods at least 16 to 20 feet apart. You should consider 12 feet as a minimum. What is wrong with placing ground rods close together? Now, this was Dennis's problem. Can anyone tell me what's wrong with putting them 3 feet apart, or like he did, he put them right beside his concrete footer for his tower? Yes, that's a good answer. It does raise the ground potential. But if they're close together, it functions as one ground rod, not as three. You might gain a little bit of resistance, but the earth can only absorb energy so fast. That's why if lightning hits a tree and you're standing under a tree, it may not touch you. You could be 10 feet away and it could still kill you because of the potential energy in the earth around you. Or a wet parking lot. You know, if you're in a wet parking lot and it hits a street pole 50 feet away, you might get a shock from it, you know, especially if your shoes are wet. So anyway, that is the reason why we want to space ground rods far apart. Now, going back to the picture in number 6, you see all the ground rods. There is a way to do this without that many ground rods. You know, they're showing, I don't know, probably 20 ground rods on that example. And whoever put that up definitely wanted to protect it from lightning. Does anybody know you can put ground rods farther than 10 feet deep? You probably asked me, do they make a 20-foot ground rod? No, they make 10-foot ground rods, but they make a coupler. So if you put a ground rod 10 feet down and it's going nice and smooth, I recommend putting a coupler. They're brass. You can buy them for 5/8 rod or half-inch rod. You get them off eBay, Amazon, about 20 bucks. Anyway, you tap that coupler. It's got like a little spline on the inside. You tap it on the top of that ground rod. It stops halfway down, and you put your next ground rod into it, get back up on your ladder, and you start driving the next ground rod. So a lot of cell towers, they'll put ground rods 40, 60, 80 feet deep, maybe 2 or 3 of them. And it all has to do with the ground resistance. Remember the ground meter I was talking about a few minutes ago? They can measure it. They have the $2,000 meters, and they'll put enough grounding in until their resistance is lower than the utility companies, okay? Which is pretty good. And you're looking at, I think Anthony once told me less than 5 ohms to ground was ideal. And if you put one ground rod in, you might have 40 ohms, if checking it with a meter. You go 20 feet deep, you might have 20 ohms. You go 30 feet deep, you might have 10 or less. So the deeper you can go, the better. Then you only need one ground rod. You don't need 10 or 20 or 6 of them 12 feet apart. It's all about how deep you can go. If you can't go deep because of rock or shale, then you got to spread out. And some of these cell towers you see up on mountains and stuff, it's so rocky, they have to dynamite and drill and everything just to get the foundation put into the rock. So their grounding is a problem. That's why they use the screen, the wire mesh. They'll expose a big area of ground, put in wire mesh because it lowers that overall resistance to ground. But a lot of them will do that and try to put some ground rods in. They'll try. I've seen some cell towers. I've been at the base. They'll have copper wire stretched all over the place. You trip over it if you're not careful, and they got ground rods everywhere you can look. You know, maybe 15 or 20 of them. But they run that copper strap all the way to the top. And you know, a lot of people think if you're going to take a lightning hit, everything's toast. That's not true. What we did on our towers is we decided to put a 6-gauge copper wire all the way to the top. And for a ground electrode, these towers didn't rotate or anything, everything was fixed. So at the top, we stuck a piece of 1/2-inch copper water pipe. And we bonded the ground wire to the copper pipe, or we run it up inside the pipe to the very top. Because most of our antennas were down 10 feet below that. So that 6-gauge copper wire, when it came down the tower, we put it on a leg that no wires were on to try to keep any magnetic flux away from our shielded cables. So it went down to the bottom, and the first 2 towers we put up, like I told you, we had 3 steel rods. We still had some problems, and the problem was it had a 110-volt feed from a nearby building about 300 feet away. So when the tower took a hit, we pretty much stopped blowing our equipment. Most of the equipment would survive, but it would trip the breaker because of the potential energy. There wasn't enough grounding in the area to compensate for the energy going back through the AC. And it wasn't just going through the ground, they were bonded together. It was 10-gauge wire, it was going through the AC wires. You know, that's why it was tripping the breaker. It was finding a good ground back at the electric company, and it was following it back. It never burned any of the wires. We quit burning outlets, quit burning equipment, but it still would trip the breaker. So after a storm, a lot of times we drove out there and had to turn the breaker back on. Didn't damage it, so we had a pretty good ground, but not quite enough. So anyway, that just told me, got to go more. Need more lower resistance to ground, more grounding rods. So anyway, go to part 7. Can I have too much grounding? A good ground is very important, maybe the most important thing in mitigating lightning damage. The more energy you convert to ground before it gets into the house or equipment room, the less you have to deal with through lightning and surge arresters. Most importantly, more energy diverted to ground means less can go through your electronics. Does that make sense? That's pretty much the whole topic of our discussion, is that phrase right there. Section 8, National Electric Code 810-21, outdoor antennas. Now this is what the National Electric Code says. The bonding conductor must be copper or other corrosion-resistant conductive material, stranded or solid. So you don't have to have stranded, you don't have to have solid, you can use either one. Can be bare, covered, or insulated bonding conductor, no smaller than 10 AWG. Why do you think they have this rule? A lot of people don't like it, especially dish network installers. I've been to people's houses when I used to do DirecTV, and there's a dish network dish on the house and no ground. Because the installer was in a hurry, he's getting paid. They had some sort of point system. And the quicker you get done, move to the next job, more points you got, the more money you made. It was commission-based, I guess. But a lot of times they'd often skip on the ground. No grounding block, no 10-gauge wire going to the grounding block. If lightning hit that dish, it's going to destroy that 10-gauge copper wire, most likely. A good, powerful bolt will. It'll probably destroy the dish, okay? But what does it do for you if it's going to destroy the dish? Any ideas? What's the point in having that ground if it's going to destroy all equipment anyway?
Keeps it from going further into the house.
Keeps it from going into the house. What happens if it goes into the house? It gets right through your satellite receiver or your TV antenna and goes to the AC in the wall. That dish is still grounded. Even if you don't have a ground on it, it's grounded back to the AC. But having that much energy follow that coax into your house is probably going to really do some damage, possibly catch the house on fire. Some insurance companies, some insurance companies may not pay a full claim if a satellite dish isn't properly grounded, or they may go after the people that installed it.
And it potentially could, if it was grounded, still.
Yeah.
But it would lessen.
Right. It gives it a better path. That 10-gauge copper is bigger than the center of the coax or the shield.
Right.
So when lightning hits, the majority of that energy bolt will follow that path to ground. It might destroy the wire, it might not. But it will follow it directly to ground outside the house. Keep the majority, and it probably still blow your receiver. And you might see some fireworks, maybe not. Yes?
Noticing from the drawing, a lot of vertical antennas have radios. Can the radio be the ground for your antenna and also the ground for the...
No, it can't. The reason being is the guy wires, you're talking about the guy wires? The guy wires are usually an alloy and they're not as conductive as copper. Now I have seen some people put radio towers up and they run a copper down to a building ground or something instead of grounding the tower directly, which it's better than nothing. I would still have an independent ground of the tower. The reason why you want an independent ground and not rely on your building ground, people say, well, why can't I just run a 10-gauge wire to my house? You can, and it's better than nothing, but what happens if that 10-gauge wire gets broke? It gets pulled off by the lawnmower, the dog chews it in two or something. All of a sudden you don't have a ground at your tower. Now you're at high risk of burning your house down again during a lightning strike, because if it hits the tower, you know where it's going to go. It's got to go through your coax. So it's best to have a good grounding system on a tower, or any outdoor metal structure basically. Then have it bonded to the house too, but you do want two independent systems. But yeah, guy cables themselves, a lot of your big towers I've seen, they actually run a ground rod at the end of the guy, and we did this too on several of our towers. We put a ground rod at the concrete base where the anchors were, because we had equalizer plates. Then we used a 6-gauge copper and we had it clamped to every guy wire, because our 150-foot towers had 5 sets of wires. But it wasn't to ground the system. It's in the case lightning hits a guy wire and not the tower, it could shoot down into the ground, take most of it that direction instead of back up to the tower and back down the other way. So you could dissipate more energy that way by doing it. But the guy wires itself are not that conductive. Most of them are steel alloy, like the EHS, Dennis. Do you know what it's made out of? It's definitely steel. It doesn't rust, but steel, zinc, I don't know. So anyway, that would be a no to that answer. I wouldn't rely on the ground wires or the guy wires.
Are you referring to the radials that are used?
Yeah, I was talking about the radials that you put into the ground. You put it below
Oh, just
the,
copper?
Yeah, the
Yeah,
copper.
yeah, yeah. That's good. You want a lot of it, depending on your resistivity to ground. If you want to check your ground, I'd recommend a meter. You know, Amazon's got some cheap ones for $200 or less that would probably give you a pretty good result to try to get your ohms low. But a lot of that would depend on how good your soil is. You know, like if you're in Florida and it's sandy, you probably don't get a good ground doing that. You're going to want a deep ground rod. You want to drive a rod 40 feet in the ground. But if you got a good enough ground rod, you only need one, you know.
If you're going to use the radials to provide a ground
Mhm.
for your vertical or your tower,
Mm-hmm.
then it has to be connected to the tower.
Yes.
And if you're using the tower as an antenna,
Mhm.
you won't always be bonding to that directly, particularly if you are using the
You talk about where they have an insulated tower
If you're
section?
using an insulated tower.
Yeah, you're kind of screwed on that one. you can't really run a copper wire to the top. Yeah. About the only thing you can do there is put lightning arresters in your coax cables, good ones, you know, where your antenna feed is. Because if it takes a lightning hit, you know, if you got an insulated tower, like I know some AM radio stations like WJTH, I believe they have an insulated base on their tower. They have long wires going up the tower, but they had to insulate the base, and then they'd put insulators on the guy wires because the tower was grounding out too much of the signal, if that makes sense. AM radio has long vertical wires, maybe 100 feet long, stretched up the sides of the tower, and that if the tower's grounded, it grounds out the signal, a lot of it. You know, it reflects it or something. So I know a lot of AM radios, they put an insulator section in the base of the tower and ceramic insulators on the guy wires. So I haven't seen a lot of them done that way, but I've seen a few.
On a freestanding tower, it'd be easy to ground like that. And when you got one standing next to a building like mine, you don't have that option of grounding that third leg like we is.
Well, you don't have to put them necessarily in a circle. You could take them out in the yard, turn 20 feet. One this way, one this way.
Running the line.
Right, or like I said, try to go deeper. How many people have drove a ground rod in the ground? It's not much fun, is it?
Many times.
Not much fun.
And I have had to cut one off.
Yeah, yep. Look at the back for a second. I put a few example pictures. Look at, I think it's, let me see which one it is. Yeah, the bottom picture. That was my son Ryan when he was about 11 years old putting in the ground rods for us. You notice what he's using?
Hammer drill.
Hammer drill. And you notice what we did? A six-way radial. That tower there could take a lightning hit and never did blow any equipment. We used 6 copper rods, put them about 12 feet apart, buried the wire about a foot deep. You notice we had a little backhoe there, so we dug a trench. But we actually dug down about 2 or 3 feet, then drove a ground rod way down in there, so the rod was probably more like 15 feet, or not 15, but 13 feet down, and then backfilled it all. But that tower was a 120-foot tower. It was out Dews Pond Road a ways. The day we turned the power onto it, we had a tower climber up there putting radio equipment up. We actually turned it on. We're testing the equipment. About an hour after he came down, a storm came up, and I was standing there, and that thing took a lightning hit. Scared the crap out of us. We were about 200 feet away. We were under a carport. It was at a friend of mine's house. We were standing there talking about it, and I said, I wonder if that thing's going to get hit by lightning. About that time, it took a lightning hit. Didn't hurt a thing. Everything, it's like it didn't even hiccup. You know, the radio equipment still worked. Everything was fine. That's the first thing we did is hook up a laptop and make sure everything was still running, but it was. So
I like the hammer drill idea.
the hammer drill is a lifesaver. Dennis is talking about doing some new ground rods, and I said, we're going to rent a hammer drill because I'll probably help him with it. You don't even have to push on it. You get a big one like a...
Well, it doesn't mushroom the head.
No, it won't. You can buy a bit for a hammer drill that fits the guy wire, but if you get a big enough hammer drill, you can just stick it right on top of the ground rod. You know, it's not going to hurt the hammer drill. Those bits you put in there, it hammers on them all the time. You're not going to hurt that hammer drill. So we just stuck the whole chuck and all right on there, and you just pull the trigger and just watch it sink down into the ground. You can do it with one hand. You don't have to even have to push on it.
Things where people have like infused water when they're driving in ground rods
Mhm.
to help them go down easier.
Hammer drill is the way to go, especially in Georgia clay. But it takes no effort. 11-year-old, he did all 6 of those with a generator and I think it was a Bosch hammer drill. We rented $37.50 for a half day. It's a lifesaver. But he put them all in like it was nothing. 11 years old. No hammer, no sledgehammer, no nothing.
And bragged about it.
He said, "Dad, this is easy." The hardest part, we had a step ladder. He had to get up on the ladder to get started, you know, because even though we had about 3 feet in the ground, it was still 7 feet out of the ground.
Drive it through some like rock.
Sometimes you hit a rock, you just keep on going, they'll bust it eventually. Now, if you hit a big boulder, your ground rod's liable to turn. Or if it's a big slab, you can't get through it, saw it off with a hacksaw and try again. You wasted that rod, try another one. Just keep adding to it if you have to. But if you can, we should have done those rods deeper. But we had 6 of them, so we thought we had a pretty good low resistance to the ground. Never did check it with a meter.
You said, so I was unfamiliar with the coupling.
Mm-hmm.
But,
I didn't even know about those then. If I'd known about them then, that ground was so soft, that hammer drill, 2 minutes he had a rod in. We could have put a coupling and probably gone 20 feet.
Have like a sit screw that,
No, it's molded to where it's not hollow all the way through, but it's got a hole in each side with a spline. They're probably about that long. They're slightly bigger than the rod, maybe 1/8 inch. So you just tap it on there.
line actually.
Yeah, a little spline to dig in, yeah. So you can get them 5/8, 1/2 inch. You tap it on top of the rod, you know, when you're down to about 3-4 inches up, stick another rod on there, tap on it, and start going. It just keeps pushing. So as long as your ground allows for it, just go deep.
Where do you get those, this line?
I seen them on Amazon. Yeah, they're about
Home Depot,
$23.
I mean, like,
Hmm?
does Home Depot and the
No, they don't.
commercial, I mean, the
No.
electrical suppliers carry them around here?
Some of the commercial ones might, but this is more for lightning protection systems. Most of your requirements for building grounds only require 1 10-foot ground rod. But for better lightning protection, you want lower resistance to the earth. So the deeper you go, it goes up drastically as you go deeper. So if your ground's not too rocky, you might get 30 feet deep in some areas. Go ahead.
How effective are the gas discharge tubes, and are they effective?
We had them on our network cables, even though we had good grounds on the tower. To make a long story short, we got to where we weren't blowing $2,000 worth of equipment because that got pretty expensive pretty quick after 3 or 4 lightning hits. And most of those towers took a hit 3 to 5 times a year. Just about every time there's a good lightning storm, it probably took a lightning hit. Occasionally a triple breaker. That's happened more than once.
Have you seen the DX Engineering grounding systems? They make a.
There's some pretty elaborate ones out there.
Yeah, it's right, and it's.
Oh, the chemical?
Well, yeah, but what it uses is the cable from your coax,
Right.
and it's all outside. You drive the rod down, and are they any good? Or?
Probably are. I've never used anything like that. I know what you're talking about, though.
But a friend of mine has the 18 HVT tower that's a whole
Right.
thing is an amp tenor.
Right.
And what he did, he took, they sell that grounding rod to go with it,
Mm-hmm.
with, like 30 different poles
Right.
sticking up. They
Right.
hook your radials to,
Okay. It's like a hub
right.
for your ground, yeah.
And what he did, he bought an edger that goes down like 4 feet, I mean, not 4 feet, 4 inches.
Yeah.
And, he just
For his
run
ground,
it
for his
out,
radials, yeah.
put a cable out.
Yeah, it does not hurt to bury your radials. You can mow your grass over them. Bury the whole ground rod. Like I said, we put our ground rods, the top of the rod was probably almost 3 feet deep. And we run our radio was a foot deep at least, and we'd go down and clamp it to the rod. Once we got it nice and deep, then backfilled everything, so you didn't even know they were there. Now we used the brass clamps, like you get at Home Depot, to clamp the wire to the copper rod, the copper clad rod. Yeah, a lot of professionals like to fuse them. They use like a hard solder, kind of like the hard solder they use on air conditioning tubing. They'll hard solder them to get even a better connection.
There are exothermic weld
Mhm.
kits
Right,
now
right,
that you can buy,
right.
and you might need to wear
That'd be even better.
face protection.
That would be even better, yep, yep. But any sort of hard copper solder where you use like MAP gas or a acetylene torch, you can solder your wires together and get even a better bond. The tower we put out in Snorville was one of the first 150-foot towers we put up. We just had galvanized ground rods, and we used a clamp for the wire. And after the first lightning hit, you can see black burns around those galvanized rods. Because, yep, where the clamp was. Probably because of dissimilar metals, you know, copper and galvanized. You can do it, but it won't handle the current of a lightning bolt. It arced right there. I forget what we did to fix that problem, other than put more clamps on it. So,
I don't know if no locks would, especially wouldn't have.
yeah, because I mean, you're already working with galvanized there. It shouldn't corrode anyway.
I think I remember we went back and picked up copper.
We might have put some copper ground rods in beside them. I can't remember.
Did.
But we didn't put them far enough out. We had them 5 feet from the tower. They were only out 2 or 3 feet from the base, probably a 5-foot circle. And that's why it was always tripping the breaker. We had 6 rods total. We had 3 at the tower base, and we had each guy anchor grounded too. But it didn't stop blowing equipment until we put a 6-gauge copper up to the top.
Go
ahead, Steve.
Electrician's handbook advise against soldering ground rods because of the lightning.
No, maybe for a house. I don't know. A house, they may not recommend soldering them or bonding them that way, exothermic. But for lightning, I mean, we got by without doing it, probably because we had enough ground rods, enough locations. Now, we didn't have any burns on clamps with a copper-clad steel rod. Nothing, you couldn't tell. In fact, that tower has been taken down. It's at Dennis's house right now. So Dennis, they know you have it now. In case anyone needs any tower sections. But we just put a 1/2-inch copper pipe at the top, and I've seen that tower get hit by lightning, and my friend Chad, it was on his horse pasture. He said every time it stormed, it probably got hit. But the top of that copper pipe, you couldn't tell it. There was not a single burn. Dennis saw it too. You'd think there'd be some chunks missing out of it, but there wasn't. So the copper pipe was handling the current just fine. You could not see even the slightest burn mark around the top of that copper. But yeah, maybe it just never got hit by a megabolt. You know what a megabolt is, 10 times more powerful than a standard bolt.
I think it'd be melted.
You think you'd see little chunks of copper missing, but I was kind of surprised. So anyway, it is possible to protect your equipment. Think about how you're grounding your stuff. If you don't have any copper ground rods, I would highly suggest you put them in, because when it comes to lightning, it's not if you're going to get hit, it's when you're going to get hit, because eventually it probably will. I bought a house 7 years ago. 3 months after I moved in, it hit a tree in the backyard, and it arced over and hit parts of the house. It blew out. I had 5 houses in the area all lost their cable modem or their satellite dishes. It was a powerful bolt, but killed a big oak tree. But it jumped out of that oak tree somewhere, and it hit an extension cord I had laying in the backyard, which was plugged in the house. Burned a hole through the side of the extension cord, and well, yeah, there was a cinder block wall with rebar in it. A piece of that was missing. There was a car sitting back there. It arced through the car, got to the house anyway, through multiple devices. And it found the ground and the electrical plug inside the house. But it also got into the network. I think I had a outdoor TV antenna, one of those little HD antennas. It was burnt. I think it also arced out of the sky and hit that at the same time. It's probably one of those bolts you see where it hits like 10 things on the ground at one time. Yeah, it hit the other houses. Our neighbor's son, he was on his computer, got electrocuted. It didn't hurt him bad, but he got a shock. Came in through the cable modem somehow, but I know Comcast took about 2 weeks to fix everybody's modems.
Mine got hit too.
And they all blamed me. So,
Should have that grounding.
yeah. But I did have I had my TV antenna grounded, but it just your typical grounding block with a 10 gauge wire. So I don't believe I took any damage to my TV, but it did blow up the antenna. So it must have arced over and hit it.
Quick little story, when I was little, it started coming up a storm, I was laying on the floor in front of the TV. My dad said, get back from that TV. So I went and got something out of my room, come back, sit down on the couch.
Mm-hmm.
Just had to sit down on the couch. The directional rotary it ran in,
Mhm.
the directional rotary
Blew it up?
on top of the TV exploded. It
Yeah.
hit the TV, but that
Yep.
directional rotary just come into pieces.
Followed that copper strap down.
Yeah.
So for the rotor, it probably had better, what they use, 4 wires, I think, on those old
Yeah,
directional,
yeah.
probably had better copper there than the actual TV wire. So that's where most of the energy,
Going to the
yeah, most of the energy came down the rotor wires. So it just goes to show you, the larger the copper, the better. Now, we use 6 gauge on the towers. If you got the money, go for 4 gauge. 4 gauge is even better. You're not going to destroy a 6 gauge wire with a lightning hit. But the better, the lower the resistance, the better is what I'm trying to say. So get something up your tower, 6 gauge, 4 gauge solid, stranded, copper strap, whatever you can afford, and then just make sure you got some good grounds. Either one deep one or multiple, like a radial. Whatever you have, bond it back to the house with the same size wire. Run a 6 gauge in a trench, along with your, maybe not right against your antenna wires, but beside them. Yes, go ahead.
What's the deal with copper strap?
Just lower resistance, a lot more copper. A lot of your cell towers, they have like an inch wide copper strap, and then they clamp to that. Different various antennas. Everything on a tower, I don't know if I went into that, but every part of the structure should be grounded. Even the tower itself. If you run a 6 gauge copper up the tower, you should still bond that tower to that copper wire. That is now your lightning arrestor. That copper wire is your path to ground. So the tower is now a part of that grounding system, but you need to bond it too. So get some sort of clamp and hook that copper to the leg of the tower. It wouldn't hurt to do it up high too. If lightning,
Oh, so you should bond each tower, 10-foot section to the.
I don't know if you got to do each one, but I'd do the tower somewhere. I've never heard that. That's a good question. They're usually connected pretty good because most towers galvanize, and the zinc is a pretty good conductor. Not as good as copper. It was on the chart here. Well, 2 ohms per 100 feet is what a Roan tower. If it was solid steel and no zinc, it'd be 5 ohms. The zinc itself conducts somewhat. So I actually calculated that based on resistivity is 0.059 microohms on a 39-inch square block. So figure out how much zinc's on there.
Rob, was one bonded at each set of guide wires as well as top and bottom, like you mentioned earlier.
Yeah, you could. You could. I know cell towers that use guys. They do bond all the guy wires. Like Bert Coker up in Dalton, I've been up there at his tower, up on Doug Mountain, and all the commercial towers up there, they have a copper wire clamped to each guy wire, and they have a ground rod. So they're definitely doing it at the ground. I can't tell if they did it at the top. That might not be a half bad idea, depending on the size of your tower and how big it is. Having a copper to the top, lightning will tend to seek that out more than it will the guy wires and stuff. What happens is lightning's unpredictable. Since your antennas also have a copper wire going up, lightning could still hit an antenna. It could fork over from the side and hit an antenna on the side of a tower and not the copper at the top, because it still found a good ground, the coax or whatever you got going down there. So you can still take damage, but the whole point is to keep it out of your house. So the more copper you have, the more secure you'll be, the better you'll feel when you're out on a trip and there's a lightning storm back home. Is my equipment going to be blown, or is it going to work when I get home? If you ground it right, it'll probably work.
One question,
Yeah.
about using bonding your radials, your antenna, your
Mhm.
is that typically, a ham radio operator will not use long lengths of whatever you're using unless you're using a non-metallic.
Right, right.
So you use non-resident lengths, so you'll have insulators breaking out of that all up. So
Right.
it's probably not that important to ground your radios if you're not using long lengths of.
Probably not. Probably not. If you're getting out there a ways, you know, maybe a different story, but if you're got short lengths, I don't think it'd make any difference. But like we were talking about there, if you had insulated tower, the only way you can protect it is to put a good surge arrestor on your coax. And hopefully the gas discharge tube in there will grab most of it. Some of them are rated 10,000 amps for 2 microseconds, so hopefully that would arrest most of a lightning bolt. At least keep the fire outside, not in the house, you know. So, but if you have a solid steel structure or solid tower, give it a good ground. And, you know, it costs money. That copper wire 6 gauge is 70 cents a foot. 4 gauge is $1.10. But one of the two is what you need to use, in my experience. Put you in 1 deep ground rod if you can. If you go 30 feet deep, that may suffice, you know. The deeper the better. I don't have a meter. Couldn't tell you exactly how deep you need to go for your soil, but I would say keep going until you can't go no farther. 40 feet would be even better. So I guarantee there's a lot less digging if you can just do 1 rod real deep versus putting them all over the place.
The rent runs out on the hammer drill.
Yep. Until the rent's up on the hammer drill. Yep. Keep going. But you'll spend less money probably with 1 deep ground rod, which I learned that after a fact. I probably would have went that path on some of the towers we did. There's other types of grounding. I've seen chemical grounding. Has anyone heard about that? They bore a hole, like a foot diameter hole, 30 feet deep or whatever, and they put some sort of copper electrode in there and they fill it full of some sort of very conductive chemical. It's probably like a salt type chemical. And its resistance to the earth, instead of having the resistance of a little 5/8 rod, it's the resistance of a foot diameter rod. Right, so it gives it more surface area with this conductive material. They mix it up in bags and pour it in the hole till it's full and it hardens. It's not cement, but it's very conductive, almost like a cement. I don't know what it's called. Has anyone ever heard of that? I've read a little bit about it. It's not cheap stuff.
Well, that's what I was thinking, because if you take like a 30-foot rod and say you hit water 20 feet down, and the water is like 10 feet deep, I mean, would that be better or worse?
Well,
I'm just wondering, because water conducts electricity.
the deeper you go, the damper the ground gets, and I assume that has a lot to do with your resistance to ground.
Yeah.
Pure water does not conduct electricity. Most people don't realize that. What makes water conduct electricity, if I was to stick a bowl of pure H2O on the table, I could take a 110 volt cord, stick it in one side, and I could touch my finger on the other side and I wouldn't get shocked. Now you think I'm crazy. What makes water conduct is the impurities in the water, minerals.
All right.
Yeah, you take pure distilled water, it's not conductive. Distilled water doesn't conduct. Salts are very conductive, minerals, dirt, dust, you know. Saccharin, whatever. Take Pepsi-Cola, it's very conductive, you know.
Very iron-rich water.
Yeah, iron-rich water, but pure water does not conduct. So keep that in mind too. But most of groundwater's got a lot of minerals, so it's very conductive. Well water's going to be conductive, yeah. So yeah, it's just the deeper the better. But if you really want to know for sure, get a meter. Invest in a meter. Let your friends borrow it. Everybody in here probably want to borrow it. If I had one now, I'd be glad to loan it.
And make it pay a deposit.
Yeah, make a deposit for it, yeah. But they have them on Amazon. I've seen some, maybe $200 for a basic. Yeah, it comes with a couple test probes you stick in the ground. You hammer them in about 2 feet, and it samples the difference between. I think you put a probe at 30 meters, or 10 meters, 30 feet roughly, then another one at 60 feet. And it can measure how conductive the ground is between the 2 probes. So when it measures your ground rod, it can give you a good estimate. Like you're 5 ohms to ground, or 2 ohms to ground, or you're terrible at 100 ohms to ground. You got to go a lot deeper.
All right.
So, anyway, any other questions?
What would you do to ground like I use, the Cobra Ultralight, everybody knows it, but, it's bred with, 450 ohm ladder guide.
Mm-hmm.
Like you get, I've seen the ones for like, coax, you know, where they have lightning protecting switches.
Mm-hmm.
But, I mean, my 450 ohm goes into the tuner.
A lot of guys, I'm not real familiar with what you're talking about, but a lot of guys like, any of you all know Don Starkey? Is Don Stoll a member of the club? Joel knows. He runs the Christian radio station over at the Georgia Cumberland Conference, and they were having lightning problems. Every time they took a lightning hit, it was blowing out their transmitter. So he knew I knew a little bit about it. I don't claim to be an expert, but I've got a little bit of real world experience, and I know what works. So first thing I asked him is, do you have a copper wire going to the top for lightning protection? He goes, no, we just have the legs of the tower grounded. I said, well, there's your problem. It's finding the copper from the antenna, it's jumping right into the conductor, and they were stripping the outside of the cable. I forget what type of wire it was. It was pretty heavy cable for that FM radio. They would strip the insulation off the top, and they were soldering a clamp to the outside and grounding it to the ground rods. And I told him, I said, that's great. You should do that on big cable. You know, ground your shield in case lightning hits the outside of the wire. I said, but what happens when it hits the antenna? It's not looking at the outside of the wire. It's going to go down the center conductor. You have no way of stopping it unless you give it a better path. So I got one of my tower climber buddies, and we climbed that tower for him and I think we used a 4-gauge. They splurged, put a 4-gauge wire up, and then
Run it above the antenna.
yeah, we run it above the antenna. We actually had to use a copper rod of some sort. We might have used a piece of 1/2-inch water pipe because they had a little antenna almost at the top, so we went up beside it. And we were worried about deflection, if it'd make a dead spot on that side, but we couldn't detect it. After we put it up, he said nobody complained. You know, it was still radiating good because a little 1/2-inch copper rod up there wasn't really grounding any of the signal. It was probably, we spaced it out to about 2 feet from the antenna because the antenna's hanging on one side of the tower. We put a copper rod right here about 4 feet higher. So if it takes a lightning hit, it's most likely going to hit that, not the antenna. It's got a lower resistance to ground. So he did that, and I don't think they've had any failures. I don't think they've had any downtime, no more blown transmitters. So made a world of difference. It was simple. It cost, they already had a lot of ground rods. I think they had 5 or 6 ground rods. And they were all bonded to the tower, so we brought that copper down, we hooked it to this ground, looped it around to this one, hooked it to the existing copper. And as far as I know, they haven't had any more damage because I see Don about once a month. He would have told me if he had.
That wire was cheaper than the train.
Yeah, $200 probably. And I think we had to pay the tower climber $100. Go ahead.
Can you cover this business of putting a copper ground wire around the building?
That is your ideal type of ground. As far as all the ground, the wire going around the building, I don't see a point for that unless you were going to put ground rods up on top of the building. You know, the lightning rods that you put on barns and houses. If you were going to do some sort of ground, like say you had a house up on a hill somewhere, and every time it rained, you got hit by lightning and damaged something in the house, then you'd want to run some straps or wires up to the roof, put a couple of lightning rods up there. Mm-hmm. I've never. They got more than one ground.
Next time Charlie's at the club, ask him about his ground rod
Mm-hmm.
around the house and what he has on the roof. He got struck one.
I think it's to lower. If you have multiple ground rods around the house, and like I said, that's like your ideal situation, the way that picture is. But if you had multiple straps coming down, one hooked on this side, one on this side, you don't want the power here have to go all around the other side of the house. You want to get in the ground as soon as possible, so you have have a perimeter. I'm guessing that's what it's for. I don't really have much experience in grounding buildings, but that would be my thoughts by looking at that picture.
I've heard of several hams doing that.
That might be a little overkill, but
Yeah,
you know, if you're out in the middle of a field and
they're all overkill guys.
mm-hmm, that whole project there is overkill. There's, like I said, there's probably 25 ground rods in that picture, at least 20. But the primary thing is they're showing you got to space them out. You can't put a cluster of ground rods in one spot, you know, beside your tower. they're going to function like one ground rod. You got to, the ground does its best dissipation at 12 or more feet. You know, so when power is going into the ground rods, you know, it's dissipating into the ground. A radio like that going straight out is probably almost as good as a ring. The ring, I guess, would carry it out a little farther if you had more ground rods. That picture doesn't show a deep ground rod, but I think from what I've read, a deeper rod is even more efficient. If you want to just guess at it, go deep.
Everybody I know that has a tower
Uh-huh.
goes out from each leg a foot.
Yeah, that ain't far enough. You might as well just put one ground rod and be done. The ground just can't absorb the energy fast enough. You can do it if you go real deep. That's why I said go deeper than if you can't go deep, if your ground's too hard, then you need to spread out. You know, a mesh would be expensive. You got to get a dozer out there and dig down 4 feet and bury it. But you can dig a little trench, like where you were saying you got a edger.
Edger.
Yeah, dug a trench about 4 feet deep and lay the wire down in it. That's one way of getting it below the ground so you don't run into it with a mower and tear it up.
Yeah, right.
But get out away from your tower. You go out 20 feet, be
That
better.
brother was, I haven't seen him home in here, but you know, he it digs a big long trench.
Ditch witch or something? Yeah,
Yeah.
yeah. Yeah, that can be expensive to rent one of those, you know, $175 a day or something. Beats using a shovel. But depends on how deep you want your wires and what type of ground you have. But the idea is to get the lightning away from the tower, get it to absorb into the ground. Think of absorption. The more copper you have in the ground, the better it's going to absorb. And keep it from following a path back to the house or building or whatever you're running. On the back, I had a couple of pictures there. Also, before I end, we're going to talk about solar panels for a minute. You can see the radial ditches we dug for one grounding system. That was the best one we did. We never had a problem on that tower. Picture of our tower guy about 150 feet in the air working on one of them. We put those towers up by hand, gin pole. Solar panels, that is a picture of my house. And if you look at the picture on the right, I've got a grounding lug on the solar panel with a 6-gauge copper wire.
Is that what that is?
Mm-hmm.
Oh, okay.
This is what they call a lay-in lug. The same rule for antennas go for outdoor structures on your house, any metal structures. When you do a solar array, each panel's grounded. I've got a 10-gauge wire going all the way around that thing, and every single panel's grounded to that wire, and it's bonded to my house ground. The reason for that, I make some YouTube videos where we put up some fairly large solar arrays. We did one for Dr. Schwamback in Adairsville, 11,000 watt system, big array.
Wow.
And we did the same thing with it. We grounded it all real good, and we actually put several ground rods in and bonded it back to his house. The idea is if that gets hit by lightning, and it could, it's up on the roof of my house.
Right.
I don't want it to go into my copper going down on my DC side and blowing out my solar inverter. Because I got a grid-tied system where it makes power and sends it back to Georgia Power with a special meter, bidirectional. So you want a good ground on that. And when I made some YouTube videos about this, people were saying, why are you running that expensive copper wire to all the solar panels? Because it's a steel frame holding all the panels. And they said, if it gets hit, it's going to follow the steel frame. All you need is one wire going to the whole structure. And I said, wrong. I said, the steel is not as conductive as the aluminum or the copper. The panels are aluminum, so if it hits, I'm hoping it jumps right into the ground, stays out of the inside of the cells.
Yeah, right.
Otherwise, it'd damage the panel and blow up my inverter. So I've had that going for 2 years, no problems yet. I don't know if it's been hit. If it did, I probably wasn't home. But it is very well grounded, just in case.
You have a shingle roof?
Yep.
What if you had a metal roof?
You still got to bond every panel.
Oh, right.
Yeah, like I said, don't trust the steel to conduct very well.
Right.
If you're on a metal roof, even if the metal roof's grounded, that solar panel takes a hit, the lightning's going to hit the aluminum, probably jump right into the solar panel, the cell itself, right through the glass, come down your copper wire and blow up your inverter. I've got a disconnect anyway, just in case. If a bad storm's coming, sometimes I'll pull that disconnect. I don't want to blow, $750 inverter. Hey, go ahead.
On the center picture,
Yeah.
the tower
Yeah,
and the trenches,
yeah.
you've got multiple trenches.
There's 6 total.
And is the rod at the end of
The rod is at the end. We dug the hole deeper at the end, got that rod down in the ground as far as we could,
Yeah.
run our copper down to it, bonded it, then backfilled it.
So does each, the 6 copper wires go to the top of the tower?
No, they're all bonded to one wire at the base of the tower.
And you have one going to the top?
The one going to the top, right. And that actually worked well. If I had to do it again, I'd probably use 4-gauge wire, but never had any equipment failures. And that, Chad, the guy that has the property, that's 200 feet from his house. He said about every time a storm came up, he heard it get hit by lightning. You know, just right there outside, he could tell. So everything just kept right on ticking now. So you can avoid lightning damage.
When you use this, do you typically put the antenna on the side of the tower?
On those, we had them on the side. They were probably 5 or 6 feet down from the copper pipe up there, which was our lightning rod, basically. We just used copper pipe because it was cheap. I mean, I guess you can get a solid copper whip or something, but copper pipe made sense to us at the time. Just clamped it to the side of the tower, and then we used a copper bolt and hooked our ground wire to that copper pipe.
Cartersville, or the Bartow County Sheriff's
Mm-hmm.
building, they have these things that look like porcupines.
Yes, up on the top of the tower. Are they like
The building,
on the buildings too?
yeah, are those,
Some people think they dissipate static during a storm. That's not what they're there. They're there to get hit by lightning. Okay, cell towers do the exact same thing. You can't always see them from the ground, but I've seen some pictures. Anthony Hodgkin's brother is a cell climber, and he's taking pictures up at the top of the crow's nest up there where all the antennas are fastened. A lot of times they have some sort of brass or copper array sticking out over the top of the antennas. And I said, what's that for? Is that to dissipate energy so it doesn't take a hit? He goes, no, that's so it will take a hit. They want to channel that lightning to the ground because they have a good ground. If they channel that lightning, you know, people don't realize that these 300-foot cell towers, like on Fire Tower Hill, they get hit just about every time lightning goes through. It doesn't knock out your cell service. On rare occasion, an antenna takes a hit, and not the tower. So it might knock out a transmitter, but it's pretty rare. Nathan said they very seldom had to fix any lightning damage like that. They would, after a bad storm, if one of the transmitters wasn't working right, he'd go out and sweep the lines. He'd climb to the top of the backpack and a laptop. And they'd hook the laptop up to some sort of tester. They'd unhook it from the antenna, and they would test the frequency coming up that cable. Yeah, and see if he had a bad cable, you know, if it got compromised or arced from lightning. But yeah, they put those feelers on the top of the towers or buildings to give lightning a path so it won't hit the brick or the building itself. So it makes a difference. And cell towers, like I said, do the same thing. They have little rods up there to try to keep lightning from hitting the antennas down below. You know, because when lightning's about to hit, there's little streamers coming off these objects. You ever watch a slow motion lightning strike? You'll see several objects on the ground with streamers, and all of a sudden you'll see a tree, a telephone pole, a mailbox, and all of a sudden the bolt will follow one path. So give it a good path, is what I'm saying. One of the stupidest things I've heard people say is, I don't want to ground my tower because it's got a higher chance of getting hit by lightning. You ever know anyone that think like that? Did it make sense? Some people, that makes a lot of sense. I don't want to ground it because it has a higher chance of getting my light. The satellite dish, same way. But what they don't understand is it's well grounded through that center conductor. You know, if you got any sort of antenna wire going up there with a copper center conductor, it's well grounded already. You know exactly where it's going to go if it builds up a charge and hits over your house there. It's going to go right into that center conductor, right inside your house. It's going to knock your TV off the wall. And you might have to change your pants. So, anyway, that's about it, guys, unless there's any more questions.